In this video, we look at the cosine law to find missing side lengths or missing angles in triangles. So the cosine law is used in non-right triangles, so triangles that do not have a 90-degree angle. Again, for those 90-degree triangles, we are going to use SOHCAHTOA. We try to use the sine law if we can. And remember, we need a corresponding angle and side length, and we have to be given one of those two and asked to find the other for another side length. So that's how the sine law works. If we can't use the sine law because we don't have enough information, we can use the cosine law. So some people call this sort of last resort. It's a little bit more work than some of the other options, so we try the other options first, and then if those don't work, we come to the cosine law. So the cosine law looks like this: c squared equals a squared plus b squared minus 2ab cos c. You'll notice it looks a lot like the Pythagorean theorem. It looks like that because it's actually derived from the Pythagorean theorem. If we had a little bit more time, we might investigate that a little bit more and show where it comes from. But for now, I want to make sure that you know how to use it. All right, so in this example, here's a triangle. We want to find side length B. Again, our first option here should probably be to label the side lengths. So opposite angle A is side A. Opposite angle B is, opposite angle B is over here, is side B. Opposite angle C is side C, which is over here. So what we want to do now is plug values in here. I should mention, wasn't very careful with this. The important thing here really is the side length on the left side of the equal sign in my equation here matches up with the angle over here. So if we're trying to find the angle, we need the side length over here, and if we're trying to find the side length, the angle goes over here. So that's something to notice. The A's and the B's don't really matter which goes where, because it doesn't matter for addition what order we do it in, and the same happens here for multiplication. It doesn't really matter. So the really important part is this either side length you're trying to find or the angle that we're going to find. All right, we want to find side length B, so let's go ahead and do that. So in our case, we want this version of the cosine law. Just grab a smaller pen here. That's a little bit easier to work with. Let's do that. So we want this version with a b on the left-hand side. So b squared equals a squared plus c squared. So notice my equation looks different. All I'm doing is I'm swapping in or out the appropriate letters. You know, if your triangle has p, q, and r, substitute in appropriately and go from there. So I replaced my a and b up here with an a and c, which means I'm going to replace these with an a and c as well. So we get 2ac here, and this will be cos. Let's try that again. So 2ac cos. I'll try to separate that enough just so that you can see that it's a separate word, and we're trying to find angle B. And then we can substitute in the values that we know. So we don't know B, that's what we're trying to find. A in this case is 10, so 10 squared plus C, which is 12, so 12 squared minus 2 times A times C, cos 35. We can now go ahead and do the squaring, do the arithmetic. We still have our b squared over here. So 10 squared is 100, 12 squared is 144. 2 times 10 is 20, times 12 is 240, cos 35. And let's keep going. We're going to slow down in just a second. We have 100 plus 144, that's 244, minus 240, cos 35. Now, some of you might be wondering, why didn't I subtract the 240 from that 244? If you're really kind of keeping an eye on what's going on here, hopefully you've realized that this multiplication here, there's no sign between the 240 and the cos 35. That's understood to be multiplication, and that multiplication needs to happen before the subtraction happens. So order of operations is important. It's very tempting and very common to just say, hey, let's subtract that 244 and that 240. But again, ignore that because we need to do this part first. So from here, we can go to our calculators. I'm going to just rewrite this 244 so I don't forget about it. We'll go to our calculators. We'll do 240 times the cos of 35. And that will give us 196.59 approximately. And now we can go ahead and do the subtraction. 244 minus 196.59. That'll give us 47.4. And that's b squared. Again, we don't want b squared, we want b, so we'll take the square root of both sides. The square root of 47.4 works out to about 6.9. So that length there, b, is approximately 6.9 meters squared. When we're measuring side lengths, we can go to one decimal place. If we're trying to find angles, we can just measure to the nearest degree. That'll be close enough. All right, let's move on to an example where we actually try to find the angle instead of the side length. So here we have a triangle. Let me just make that a little bit bigger so it's easier to see. And we're trying to find angle A. So I'm going to start by labeling the triangle. And we'll label that triangle with all of these different values. So here's angle A. That means that this is side length A. Here's angle B. So side length B is over here. And this must be side length C. Now notice in this triangle we don't have any angles. So because we don't have any angles, it's not a good candidate for the sine law. We don't have that corresponding angle side length pair. So we need something else. We're going to use the cosine law. And we're trying to find A, angle A. So we're going to use that cosine law version that has the a squared out here and the cos A way over here on the right. So that looks like a squared equals b squared plus c squared minus 2bc cos A. And what we'll do is we'll just substitute in all of the values that we do know. So I know that A is 9.6. So this becomes a 9.6 squared. B is 20.6. So we'll square that. C is 14.7. We'll square that. Minus 2bc. So 2 times b, which is 20.6. Whoops. And then C is 14.7. All right, I just realized my decimal doesn't look very big over here. And then we don't know what cos A is, but we can't just drop it. We're going to keep it there. In fact, that's what we're trying to find. Same equation, and now we just need to find a different part of it. And so we'll just kind of work our way through this methodically. We'll square this 9.6, and that will give us 92.16. We'll square the 20.6. That will give us, when we square 20.6, will give us 424.36. And then we can square 14.7, which will give us 216.09. And then I'm just going to do this multiplication here, 2 times 20.6 times 14.7. That will give me 605.64. And again, we still have the cos A out here. Again, let's be careful of doing things in the right order, so following order of operations. It's, again, very tempting to want to just add and subtract all of these numbers here, except the multiplication on the right, it needs to take a priority before we do that subtraction. We can, in the meantime, though, just go ahead and add these two values right here. So let's go ahead and do that. 424.36 plus 216.09 will give us 640.45. So 640.45. We still have that 605.64. Sorry, that's a 0. And the cos A is still out here. Again, be careful. Don't subtract. It's very tempting. I know it looks like, oh yeah, we can just subtract there and we'll be almost finished. But be careful about that. All right, so from here, what we need to do is we're trying to isolate for A. We're going to slowly peel away the layers. We'll get this term on the one side of the equation by itself. So to do that, I'm going to subtract 640 from both sides. 640.45, pardon me. So we'll do this on both sides. Again, I'm just writing down what we're doing here so you can kind of see it. mathematically rather than just hearing it in words. All right, and when we do that, we will be left with negative 548.29. That's the left side. The right side will be negative 605.64 cos A. Next up, we're going to get cos all by itself. So we're going to undo this multiplication by negative 605.64. We do that with the inverse operation, which is division. And then do the same thing. So negative 605.64. So that leaves us with cos A, equals, and if we plug that into the calculator, we should get 0.9053. And again, we want to undo this operation of cos, so we're going to apply the inverse cos to both sides. That will leave us with A equals approximately 25 degrees. It's a little more than that, but we'll round that to 25 degrees even. So again, we found that the angle in here is approximately 25 degrees. So those are two examples on how to use the cosine law to figure out a missing side length or missing angle. Again, the key here is that it's not a right triangle and we don't have that corresponding angle and side length pairs that we need for the sine law.